Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is object-oriented programming, and the new chapter, that is chapter number 10, that is managing console input-output operation. That is how to manage the console input-output operation. That is a new topic, that is a today's topic. In the last class we have discussed with how to or what are the virtual functions and how to use the virtual functions in the polymorphism. What is the concept of virtual functions in the polymorphism? So let's start with the virtual function concept. That is what we have covered in the last class. So let's start the session again. In the last class we have discussed about the virtual function, that is a category of polymorphism, that is a part of the runtime polymorphism. So that is the concept of virtual function, that is how to use the virtual functions in the C++ or in any object-oriented programming. In the last class we have discussed how to use the virtual function that is a part of the runtime polymorphism. Now there are two categories of polymorphism. One is a compile time polymorphism, one is the runtime polymorphism. And the compile time polymorphism is achieved by using the virtual functions and the by using the operator overloading and the function overloading, but the runtime polymorphism is achieved by using the virtual functions. That is a concept. In simple terms, virtual function is a function that is used at the base class. That is, C++ determines which function to use at the runtime, whether from the base class function, whether from the derived class function, because there is the same function name that is used in both the base and the derived class. So it's the responsibility of the C++, or it's a task of the C++ to determine which function to use at the runtime, either from the base class, either from the derived class. So this is the important line. When we make the function, when a function is made virtual, C++ determines which function to use at the runtime based on the type of object pointed by the base pointer rather than the type of the pointer. So it depends on the type of object that is pointed by the, that is occupied by the, that is used by the base pointer rather than the type of the pointer. Therefore, by making the base pointer to point to a different object, we can use different versions of the virtual function. We can use the different versions of the virtual function. Then we have discussed about the example of virtual function, that is how to use the virtual function. What is the category of using the virtual function? This is the example. In this, the display function is used in both the base and the derived class. Same display function, same display function. But when we declare the display function as a virtual, so C++ determine at the compile time which display function is used, either from the base class, either from the derived class. But in this example, this display function cannot be made a virtual. But next member function is void show function, that is made virtual. So in this case, C++ also determine which function is used at the base class based on the type of the object that is created by the base and the derived class. This is the object that is created. This is the pointer, that is pptr. Now it points to the base class. This is %b. This address is determined, or address is stored in the bptr. Then display function is used, then show function is used. In the same way, bptr now execute to the derived class, or now points to the derived class. Then there is a return 0. So in this, there is a display base, there is a display base. Why both the same? Because the display function is not a virtual function, so it is executing automatically from the base class. But this show base is different, show derived is different. Why? Because the show function is different, or show function is the virtual function that is used in the base class and the derived class. So what is the advantage? The main advantage is that C++ determine which function is used at the runtime based on the type of object that is pointed by the base class. This is the example. Again, another example that is given for the virtual functions. This is what we have discussed. Then we have discussed the rules for the virtual function. That is very important tool. That is, what are the various rules? First of all, the virtual function must be a member of the class. That is, it is a member of the any of the class, either from the base class, either from the derived class. they cannot be a static member, that is they are not initialized to 0 when it is declared, that is they cannot be a static members. Then they are accessed by using the object pointer. So whenever we are using the, or whenever we are taking the virtual functions, they are accessed by only using the object pointers that is pointed by the, for example, this is the example that is given, that is pointer BPTR, that is a base pointer, that is the object pointer that is used for the virtual functions. Then there are we cannot have a virtual constructors, we have a virtual destructor, that is there are total 10 rules that we have studied in the last class. Then the next that we have studied is the pure virtual function, that is simply a function that has no meaning, or that has no argument, that has no definition, but it is always initialized to the 0. So this is the example, that is a virtual void display equals to 0. So this is a pure virtual function because it is a do nothing function, that is there is no category. The parentheses are empty, the arguments are empty, the definition are empty, there is no criteria that is fixed over here. So it only serves as a placeholder in which we have to define something, we have to cut something, we have to store something. Such functions are known as the pure virtual function. So it is a function that is declared in a base class that has no definition relative to the base class. It is only declared, but they have no definition that is relative to the, that is equivalent to the base class. In such cases, the compiler requires each derived class to either define the function or redeclare it as a pure virtual function. Then there is a summary, that is we have finished this in the last class, the 9th chapter. Summary is very important because it compiles each and everything. The first point says polymorphism simply means more than one form, that is more than one form is used. There are two types of polymorphism, compile type polymorphism and the runtime polymorphism. And compile time polymorphism includes the operator overloading and the function overloading, and the runtime polymorphism includes the virtual functions. There then function overloading and the operator overloading is also used for the invoking the function that is used in the operator over class. So compiler executes or note this information which function is used at the runtime based on the type of the object that is pointed by the base pointer. In runtime polymorphism, an appropriate member function is selected while the program is running. So C++ supports runtime polymorphism with the use of with the concept of the virtual functions. Then object pointers are useful in creating the objects at the runtime. Then this pointer is also used in this chapter, that is used to compatible, or that is used to invoke the member functions. Then there is a virtual function concept. So C++ determines which function is used at the runtime based on the type of object that is pointed by the base pointer. Then we have a virtual destructor, but we cannot have a virtual constructor. So these are the various topics, these are the various content that we have studied in this chapter. Now let's move to the new chapter, that is the today's class topic, that is the chapter number 10, that is managing console input output operation. That is how to manage the input output operations, that is what type of input we are giving to the computer, we are giving in a C++, what type of output we are generating in a computer, that is a managing console input output operations. So there is an introduction. This says every program takes some data as an input and generates processed data as an output following the familiar input output cycle. That is, every program takes some input, every program gives some output and generates processed data, that is generates the data that is available, that is a generation of the data, that is there is a input, there is a processing, then there is a output. So it is therefore essential to know how much or how to provide the data input and how to present the result in a desired form. That is why or when to give the exact data, when to give the exact accurate data, and when to process the data, or when to produce the result in a desired format. That is very important concept in the input output operations. We have in the earlier chapters used C in and the C out with the operator this and the this. That is C in used for the we can take inputting the data, and C out is used for displaying the data on the screen. So C out is used for output, and C in is used for input for both the input and output operations. But we have not so far discussed that how to control the way the output is printed. But we have discussed that this is cout is used to print the data, cin used to take the data, but how it is compatible with the C++, or how it is used to control the various inputs so that the data will be furnished in a proper manner. So C++ supports a rich set of input-output functions and operations to do this. That is, C++ has so many input-output operations, so many input-output functions that is used to do some such operation, that is how to control the data, how to control the input-output operations. Since these functions uses the advanced feature of C++ like classes, derived classes, virtual function, we need a lot about them before really implementing the C++ input-output operation. That is, we are talking about C++ input-output operation. That is a very deal, or that is a very concept that is used in the C++ controlling. Remember, C++ supports all of C's rich set of input-output functions. We can use any of them in the C++ program, but we restrained from using them due to two reasons. First, the input-output methods in C++ supports the concept of OOPs, and secondly, input-output methods in C cannot handle the user-defined data types such as class objects. C++ using the concept of stream and the seam classes to implement its input-output operation with the console and disk files. So it's a responsibility of C++ to use the concept of the stream and the stream classes. So there are two concepts. One is the stream, that is the C++ stream, and one is the concept of the stream classes to implement the input-output operation, that is which input is given, which output is generated, with the console and the disk files. We will discuss in this chapter how stream classes supports the console oriented input output operation. So this chapter is generally based on the stream and the stream classes, that is how to use the C++ stream, or which C++ stream classes will be used for the console oriented input output operations. File oriented input output operations will be discussed in this in the next chapter. So in this chapter we generally focus on the input output operations, that is a console oriented input output operations. In the next chapter we will talking about the file oriented input output operations. So let's start with the C++ stream, that is what is the meaning of C++ streams, how we are dealing with, or how C++ deals with the C++ streams. So let's start with the C++ streams. This says the input output system in C++ is designed to work with the wide variety of devices, including terminals, disk, and the tape drives. That is, input output system that is available in C++ is designed in such a way that it is work with various devices. That is, whenever we have to give the input, whenever we are able to, or whenever we want to generate the output, that is done by using various devices. That includes the terminal, disk, and the tape drives. Although each device is very different, that is, although every device is different, but it executes the same operations, like input is given to the C++ and output is generated from the C++. The input output supplies an interface to the programmer that is independent of the actual device being accessed. This interface is known as a stream. So this is the interface that is given, that is using or that is used with the C++ streams. A stream is a sequence of bytes. That is, what is a stream? It is a sequence of bytes. It acts either as a source from which the input data can be obtained, or a destination to which the output data can be sent. So what is a stream? It is a sequence of bytes. It's a combination of bytes. So whenever we combine multiple bytes, not bits, remember, what is a byte? That is a collection of 8 bits. What is a bits? That is 0 and 1. So whenever we combine the bits, that is 0 and 1, that is known as the byte. And what is a stream? It is a sequence of bytes. It acts either as a source from which the input data can be obtained or a destination to which the output data can be sent. So it acts as a source, it acts as a destination. The source stream that provides the data to the program is known as input stream. So the stream or the place from which the data can be given to the program, so means we can give the input to the program, that is known as the input stream, and the destination stream that receives the output from the program. So there are two streams. One is input stream that provides the data to the program. One is the destination stream that receives the data from the, or that receives the output from the program. So there are two, one is a program. If we provide the input, that is we provide the input, we use the input stream to provide the input, and whenever we want to display the output from the program, that is done by using the output stream. In other words, a program extracts the bytes from the input stream and inserts the bytes into an output stream as per the given example. So a program extracts the bytes, that is takes a byte from the input stream and supplies the output to the output stream. This is the example that is available with the example. There is an input device, this is the input stream, this is the program. For input device, that is for example the keyboard is an input device. We pass the input to the input stream, then from the input stream we pass the data to the program, right? Then program gives the output, so it gives the output into the output stream and provides the output to the output device. So first of all, input device provides the data to the, or provides the input to the input stream. Then input stream provides the data, provides the input to the program. Then from the program, output is generated, then provides the output into the output stream, and with the help of output device we can display the data, that is output stream is passed the data to the output device. And for example, output device is monitor screen, we can display the data with the help of the monitor screen. The best example, when we give the input, that is when I if I'm talking about me, when I write the program, when I write the code for the any program, for example addition of two numbers, that is I'm taking the input device, I'm using the input device, that is a keyboard from my laptop, from my computer, right? I pass the data to the input stream, then I wrote the program. This is the program, C++, C out, C, and anything, right? When I compile the program, when I execute the program gives the output. That output will be stored in the output stream, right? When I execute the program, there is an output screen that is available, that is displayed with the help of the output device. So this is the processing. I as a user provides the data, write the program, computer compiler as a system compiles the data, provides the output with the help of the output device like a monitor, right? The data in the input stream can come from the keyboard or any other storage device. This is the best example, keyboard, because we are typing the program. That is why it is using the keyboard, or any other input device. There are so many input devices like scanner, light pen, mouse, and any one input device we are using. Similarly, the data in the output stream can go to the screen or any other storage device. That is the output device. The best example is monitor, but we can use any output device, whether it may be a printer, it may be a plotter, and any output device that is used. So data will be sent to the output stream that will go to the screen or any other storage media. As mentioned earlier, a stream acts as an interface between the program and the input-output device. Therefore, a C++ program handles data independent of the devices that is used. C++ contains several predefined streams that are automatically opened when a program begins its execution. So C++ provides various predefined stream that is already available, that is already defined in the C++, that are automatically opened, that are automatically executed when a program begins its execution. These include C in, C out. So this is the best example, that is a C in and the C out. That is used for execution part. This in for example, we have studied so many programs. The basic thing that we are used is the C out and the C in. C out is used for displaying on the screen, and C in is used to give the input to the computer, to the program, to the compiler. So we know that C in represents the input stream that is used for giving the input that is connected to the standard input device, for example keyboard. And C out represents the output stream, as I said, that is used to display the content on the screen, that is the standard output device, for example the screen, right? Note that the keyboard and the screen are default options. So these are the default options. Why? Because when writing the program, keyboard is used. When displaying the output, the monitor is used, that is the screen is used. We can redirect the streams to other devices or the files if necessary. So we can also redirect the streams. We can also provide other stream to give the input, to give the output, to display the output, and any other streams. This is the concept of the C++ streams, that is in simple terms how to give the input, how to take the output, that is the C++ streams. Now what are the C++ stream classes, that is what are the different categories of the C++ stream classes? So the C++ input-output system contains a hierarchy of classes that are used to define various streams, that is used to deal with both the console and the disk files. That is, there's a number of, or there are so many classes that is available for the C++ streams. That is how to take the input, how to define the output. These classes are known as the stream classes. So there are various classes that is deal with both the console and the disk files. These classes are known as the stream classes. This is the figure 10.2. This is the figure that shows the stream classes for console input-output operations. So this shows the hierarchy of the stream classes that is used for the input and the output operations with the console unit. These classes are declared in the header file iostream.h. So these are all the classes that is available in the header file. That is a basic header file, that is a input output stream.h, that is a iostream.h. This file should be included in all the programs that communicate with the console unit. So this included, or this file should be included in every program that is using the, or that communicate with the console unit. Now this is the hierarchy that is given. There is the input output stream, that is iOS. There are three types of classes. One is the I stream, that is for the input. One is for the O stream, that is for the output. This is the stream buffer, that is used for the pointer. And from I stream there is a IO stream, that is the input output stream. That is a combination of the I stream and the O stream is known as the input output stream. Then now this is the stream buffer that is used for pointer. Now iStream is divided into iStream with assign variable, IOStream with assign variable, OStream with assign variable, that is the output stream. So these are the various classes that is used in the C++. So one is iStream, one is OStream, one is IOStream, one is the stream buffer, one is the iStream with assign, one is the OStream with assign, one is the IOStream with assign. So iOS is the base class for the iStream and the OStream. So this is the base class, which are in turn base classes for iOStream and the this is the base classes for iOStream. The class iOS is declared as a virtual base class so that only one copy of its member are inherited by the iOStream. So this becomes the virtual function, or this becomes the virtual base class, so that only one copy is inherited from the by the IOStream, that is the iStream and the OStream. The class iOS provides the basic support for the formatting and unformatted input-output operations. That is, the class iOS contains or provides the basic supports, provides the basic features, provides the basic classes for formatting and the formatted and the unformatted input-output operations. Formatted input-output operations means there will be a proper formatting among the input that is given. There will be proper formatting that is given for the output. That is a formatted and the unformatted input-output operations. The class iStream provides the facilities for formatted and unformatted input, while the class OStream provides the facilities for formatted output. So iStream is available for the formatted and the unformatted input, and OStream is available for the formatted output. The class IOStream provides the facility for handling both input and the output stream. Three classes that is available. For example, iStream with assign, OStream with assign, IOStream with assign adds assignment operator to these classes. So classes are the same, that is iStream, OStream, IOStream, but with assign means assignment operator is used with these classes. Table 10.1 give the details of these classes. This is the table that is given. These are the various content that is available with these classes. So first of all, there is the iOS, that is a general input output stream class. First of all, that contains basic facilities that are used by all the input and the output classes. So it contains basic facilities that is used for the basic input and the basic output operations. Then next point says also contains a pointer to a buffer object, that is also contains a pointer variable to contain or to a buffer object. Then it declares constant and the functions that are necessary for handling formatting input or formatted input and output operations. That is, it declares a constant and the functions. So there are various constants and there are various functions that is available that is necessary for handling formatted input and the output operations. Then iStream, that is used for the input stream that inherits the properties of iOS. Then that is a iStream. Then next point says it declares input functions such as getLine and read. So there are various input functions that is available in the iStream, that is get function, getLine function and the read function. Then iStream also contains the overloaded extraction operator, that is a cout operator, that is a cout extraction operator. Then OStream, that is the output stream. Then it inherits the property of the iOS, because iOS is the base class that is available for both the iStream and the OStream. So it inherits either the OStream or either the iStream. It inherits all the properties of the iOS because that is the base class. Then declares the output functions such as put and the write. So in iStream there are input functions like getLine, read. In OStream there is an output function that is used to display on the stream, that is a put and the write. Then it contains the overloaded insertion operator that is used with the cin, that is the insertion operators. Then IOStream, both the input output stream, it inherits the properties of IOStream and the OStream through multiple inheritance, because there are two base classes, so that is a concept of the multiple inheritance. So it inherits at each and every property from the IOStream and the OStream, and therefore contains all the input and the output functions. So every input and the output functions is available in the IOStream. Then stream buffer, that provides an interface to the physical devices through buffers, that is a stream buffer. Acts as a file for file buffer class using iOS files. So it acts as a base for the file buffer class that is used with the iOS files. iStream class and the extraction operator insertion operator is overloaded in the OStream class. The following is a general format for reading the data for the keyboard. So this is the table that is shown. So the next concept is unformatted input output operations. So this line says the class iOS, that is a base class, provides the basic support for the formatted and the unformatted input output operations. So it provides the basic support for the input output operations, for the formatting and the unformatted input output operations. So let's start with the unformatted input output operations. That is, what is the unformatted input and output operations, right? So let's take a break right now, then moves to this topic, that is the unformatted input output operations. So let's take a break, then come back after 10 minutes, then start with this topic, that is unformatted input output operations. So come back from the break. Now let's start the session again. Larry, your question is, what is the full form of iOS? Now you got the answer, that is input output stream. Yeah, right. Its full form is input output stream. Alright. So let's start with the next topic, that is unformatted input output operations. That is a what are the input output operations that is not formatted, that is known as the unformatted input output operations. The first one is overloaded operators, that is a extraction operator and the insertion operators. So we have used the object, that is cin and the cout, that is predefined in the iostream.h, that is a iostream file. So we have used in so many programs, that is how to use the cin, how to use the cout, because that's the basic usage, or that the basic program, that the basic function that is used. Cin used for giving the input and cout is used for giving the, or for producing the output. And this cin and the cout are available in the iostream header file, that is the iostream.h, for the input and the output of data of various types. That is, cin is used for giving the input and cout is used for giving the output of various types. Various types includes, for example, if I want to give the input in terms of the C++, that is a cin. If I want to give the output in terms of C++, that is done by the cout. So the cin and the cout are the input and the output of the data of various types. This has been made possible by overloading the operators, that is the extraction operator and the insertion operator, to recognize all the basic C++ types. The insertion operator is overloaded in the iStream class, and this operator is overloaded in the OStream class, because this is the extraction operator that is used to extract the output. So it is overloaded in OStream.h, and the insertion operator is overloaded in the iStream class. The following is the general format. That is, overloaded means more than one variables are used in one content in one line. That is cin, there is the insertion operator, there is a variable 1, then again the insertion operator, variable 2, again the insertion operator, variable 3, and so on till variable n. That is, we can overload the cin operator as many as variables as we can. This is variable 1, variable 2, variables n are the valid C++ variable names that have been declared already. This statement will cause the computer to stop the execution and look for the input data from the keyboard. The input data for this statement, that is the input is given for this statement, is data 1, data 2 till data n. The input data are separated by white spaces and should match the type of the variable in cin list. That is, it must be separated by the white spaces, it must be separated by the white, we can say the white arguments, spaces, new lines, and the tab will be skipped. That is, there is no concept of the tabs, spaces, and the new line, that will be skipped. The operator, this is known as the insertion operator, reads the data character by character and assigns to the indicated location. So this is the important line. This insertion operator reads the data character by character, not whole content at the same time, no, but it reads out the data character by character and assigns it to the indicated location. The reading for a variable will be terminated at the encounter of a white space. So whenever there is a white space, it stops reading out the data or a character that does not match the destination type. For example, consider the following code. This is the code. There is a variable that is declared, that is the int code. Then cin code, that is the whatever the value that is contained in the variable code, that is inserted into the computer, that is inserted into the input stream character by character with the help of cin. Suppose the following data is given as an input. There is a 42580. The operator will read the character up to 8. That is first of all 4, then 2, then 5, then 8, then D. And the value 4252 is assigned to the code, and the character D remains in the input stream and will be input to the next cin statement. So this numbers is given in the one cin statement, and the character, that is a capital D, is assigned to the another statement, another or the next cin statement. So two cin statements are used, one for the number, one for the character. The general form for displaying the data on the screen is using the cout, and the cout can also be overloaded. That is, we can use more than one data items with the cout also. That is the cout item 1, item 2 until item n. The items item 1 through item n may be a variables or constant of any basic types. We have used such statement in a number of examples that is illustrated in the previous chapters. Now, what are the various functions that is used for seeking out, or that is used for taking the input? That is the put and the get function. There are two functions. One is a put function that is used with the cout. One is the get function that is used with the cin. Because as the name advice, put, that is putting something on the screen. Get, that is getting something from the computer. That is a get and the put. So this says the classes iStream and OStream defines two member functions. iStream defines get, and the OStream, that is output, defines put. To handle the single character input output operations, that is, there will be a when there is a demand for inputting the single character, that is done by the get. When there is a demand for outputting the single character, that is done by the put, to handle the single character input output operations. There are two types of get functions. There are two types of get function, means there are two types of get function that is available. We can use both get char pointer and the get void prototype to fetch a character, including the blank space, tab, and the new line characters. That is, we are using the get char pointer, get void prototype to define the character, to fetch a character, including the blank space, including the tabs, and including the new line characters. The get char pointer version assigns the input character to its argument, and get void version returns the input character. So get char pointer assigns the character to the argument, and the get void returns the input character. That is, returning the input character means returns the input to the screen. Since these functions are members of the input-output stream classes, we must invoke them using an appropriate object. That is, since these are the functions, these are the members of the input-output stream classes. That is, they are the member of the IOStream class. So we must invoke them using an appropriate function. That is, we must use them with an appropriate function, with an appropriate object. This is an example that is given. There is a char c, that is a c is a character, or c is a variable that is of char type. Then cin is used with the dot operator to get c, that is get a character from keyboard and assign to the c. That is, character by character it is getting from the keyboard and assigned to the variable c. Then while c is not equals to n, that is, the condition is used that it is executed till c is not equals to null, that is a slash n, that is a not null, that is a new line. If it is going to the new line, that it will stop execution, and so it will execute till the c is not giving, or c will not assign to the, not jump to the next line. Then cout c, that is the it prints the c, that is on the screen, that is display the character on the screen. Then cin get c, that is get another character. So character by character it will print, character by character it will take the data from the user. This code reads and display a line of text that is terminated by a new character. That is, this code reads and display a line of text till it is the line of the text is complete, and whenever there is a slash n, that is moving to the next line, so it will stop execution or the loop will terminate. Remember, the operator, this is the insertion operator, can also be used to read a character, but it will skip the white spaces and the new line characters. The above for loop will not work properly if the statement is used in place of this one. That is, it is not executing properly the while loop, because if it is used, that is cin is used in place of cin dot get c. Trying using both of them and compare the result. Now the get void version is used as follows. This is the get void version. That is how to use the get void version. That is how to use the get function. So there is a char c, that is c equals to cin dot get. This is change, not cin dot get c, but it is assigned to the c variable, that is c equals to cin dot get function. The value returned by the function get is assigned to the variable c. That is, whatever the value that is returned by the function, that is assigned to the variable c. The function put, that is put function, a member of OStream class, can be used to output a line of text character by character. So it's a class of, or it's a member of the OStream class that is used to give the input, that is used to give a output a line of text that is done by the character by the character. For example, this is example, that is cout dot put x, that is the cout is used for displaying on the screen, and the put is used, that is the put operator is used to display on the screen, that is the x variable or display the character x. So put is used to display. So what will be display on the screen? That is the x, because it is a character that is given in the single quotes, so it will display as it is, that is display the character x. And cout dot put ch, that is it will display the value of the variable cout, variable ch. So one is the character printed, one is the variable value printed, that is the ch. The variable ch must contain a character value. We can also use a number as an argument to a function, that is a put. That is, we can also give the numbers with the cout dot put, that is 68. That will display the character d. Why it will display the character d? Because the ASCII value, there is a ASCII value of each number that is given. There is a ASCII, that is the American Standard Code for Information Interchange. I'm repeating the full form: American Standard Code for Information Interchange. So every values have some ASCII values, or every characters have some ASCII values. So that is, it converts the int value 68 into char value and display the character whose ASCII value is 68. That is the it find out the character whose ASCII value is 68 and print that character. Because this function or this definition says that it is a member of OStream class and can be used to output a line of text character by character. Only it will display the text, not the numbers. So put is used for displaying the characters on the screen, and get is used to taking the data from the user. Variable, this is mentioned, this is given. The following segment of a program reads a line of text from the keyboard and displayed on the screen. So first of all, there is a char c, that is a variable is defined, that is a c variable. Then cin dot get c, that is a get c is used for read the character by character or read a character, that is cin dot get c. Then while c is not equals to next line, that is, if it is not equals to next line, it will not jump to the next line. Then cout dot put c, that is display the characters on the screen, that is it will display the character on a screen. That is how to display the characters on the screen, that is cout dot put c. Then cin dot get c. Cout means displaying down the screen, then cin means taking the character by character, that is the cin dot get c. So figure the program 10.1 illustrates the use of two character handling functions. So this is the character input output with get and the put functions. That is how to use the get functions and how to use the put functions. That is the character input output with get and the put functions. So first of all, there is a hash include IO stream. So this is the header file that is used. Then there is a int main, then count equals to 0. That is the variable count is initialized with the 0 first of all. Then a character will be declared, that is a C. Then C out, that is it will display on the screen, that is input the text. Then moves to the next line, that is by using the /n, that is the input text. Then cin dot get c, that is a get is a function that is used to give the input that is done by the get c. Then while c is not equals to null, so it will display it will go on till c is not equals to the next line, that is the /n, not null, it is for the next line. Then cout dot put c, that is put c is used for display or to print the character by character, that is a put c. Then count plus plus, that is every count is incremented, that is a count plus plus. Then cin dot get c, that is a get c is used for displaying the for getting the or for reading out the or for inputting the character by character, that is a cin dot get c. So this while loop is executing till it is moved to the next line, till c is not equals to the next line, right? Then cout number of characters, so it will print as it is, that is what are the number of characters, that is how many characters I'm inputting, that is stored in the count. So there is a return 0. So if a input that is given, that is object oriented programming, output is object oriented programming, and the number of characters is 27. So there are total 27 characters that is used in object oriented programming. There is a note when we type a line of text. So when we type any line of text, for example this object oriented programming, the text is sent to the program as soon as we press the return key. So the text is sent to the program as soon as we press the return key, we press the enter key. The program then reads one character at a time using the statement cin.getC. So program can then read out the character by character at a time, that is one character at a time, using the statement cin.getC, and display it using the statement that is cout.putC. This process is terminated when the new line character is encountered. That is, this process is terminated when the new line character is occupied, or when the new line character is encountered. So this is the usage of the put and the get function. That is, put is used to display on the screen, that is character by character. Get is also used for inputting the data, inputting the character by character, not exact whole line, but it is done or it is doing character by character. Now next is get line and the write function. The same concept that is used with the get line and the write function. So we have read and display a line of text more efficiently using the line oriented object or input output functions, that is a get line and the write function. So there are two functions that is available, that is a line oriented input output functions. One is a get line function, one is the write function. The get line function reads a whole line of text that ends with the new line character. That is, it reads out the whole line, it reads out the full line, that is a get line function that reads a whole line of text that ends with the new line characters. That is, that ends with the beginning of the line that is transmitted by the return key. This function can be invoked by using the object that is cin as follows. So cin is used for invoking the get line and the write function, that is a cin. So there is a cin dot get line, there is a line, there is a size. The dot operator is used and the get line function is used, and there are two arguments, one is the line, one is the size. So this function call invokes a function that is a getLine function which reads the character input into the variable line. This is used to read out the character input, character data into the variable line. The reading is terminated as soon as either the new line /n is encountered or size -1 characters are read. The new line character is read but not saved. So it is read out but not saved. Instead, it is replaced by the null character. So the new line character is read out but not the save, but it is replaced by the null character. For example, this is the code that is given. There is a char name 20. So name is the array that is used that contains total 20 variables. Then cin.getLine, that is a getLine is used. There is a name, then there is a 20. That is what is the name? Line is name and the size is total 20. Assume that we have used or we have given the following input through the keyboard, that is Varjane start and then press the return key. This input will be read correctly and is assigned to the character array name. So this will be assigned to the whatever the character that is name. Let us suppose the input is given as an object-oriented programming. In this case, the input will be terminated after reading the 19 character, because this is total around 27 characters. So after 19 it will stop. It will stop after pro, because we have given the length, or we have given the already given the length of the name is 20. Remember, the two blank spaces that is contained in the string are also taken into account. That is, the two blank spaces are also taken in the account, including in the characters. That is, the blank spaces are also including in the characters. We can also read the strings using the operators as follows. This is the cin name. But remember, cin can read strings that do not contain white spaces. This means cin can just read one word and not a series of words such as Varjane step. That is, cin just read out only one word but not a series of words. But it can read the following string correctly, that is a Barjani step. After reading the string, cin automatically adds a terminating null character to the character array. So at the end there will be automatic null character, that is a termination of the string, termination of the line. So next program demonstrates how to use the insertion operator and how to use the get line for reading out the string. So get line is used for reading out the string and store in the memory. That is done by the get line function. So this is the hash include iostream.h. So first of all, there is a header file that is used, that is a hash include iostream.h. Then there is the int main, that is the starting of the main. Then there is the int size equals to 20. That is, we have defined the constant size as a 20. That the maximum it contains the 20 value. Then char city20. That is the one array will be declared, that is a city. That's the name of the array is city, that contains total 20 variables, 20 character, that is from 0 to 19. Then cout, enter the city name, that is enter the name of the city. Then cin city, that is the cin means in getting the input, that is a city. Then cout city name, that is city. So first of all it will get the city name from the user, then it will store the city into the computer, into the memory. Then it will display the city name as it is, that is a variable will be used, that is a city, right? then enter the city name again. Now again entering the city name, that is how to use the city name. Then cin dot get line, that is a get line is used, the name of the city that is entered and the size is also entered by the user. Now city name, now there is a city. Now enter another city name, again using the getLine function, the name of the city and the size of the total size of the array characters. Then cout new city name, then city, then there is a return 0, that is the returning of the 0. Then there is a closing curly braces that is used. So first of all, enter the city name stored using the insertion operator, then again using the cin dot get line for getting the data into the, or for getting the, or for storing the data into the line. Then there is a return 0. Now there is a closing curly braces. So the what's the output that is given, that is at the first run enter the city name, for example Delhi, the city name is Delhi, enter the city name again, the city name now is, enter another city name, that is Chennai, the new city name is Chennai. In the second run again the city name, that is Delhi, that is new, enter city name again, that is Delhi, again it is Bombay, that is Greater Bombay. Note that during the first run the new line character at the end of the Delhi, which is waiting in the input queue, is read by the getLine function automatically or immediately, and therefore it does not wait for the response to the prompt, that is enter the city name again. The character /n is read as an empty line. Now during the second run the word Delhi is read by the function, that is a get line, and therefore here again it does not wait for the city line, so it is not used for the city line. Now the next function is write function, that is used to display on the screen. Till now we have studied about the getLine function, that is how to take the input from the user, how to take the input from the user in the program, how to take the input for the program. Now next is write function, that is how to display the output on the screen. That I'm not going to start right now because it's also lengthy, we can say lengthy function. So let's stop over here only. In the next class I'll be moving, or I will be covering your next function, that is the write function. So this write function we will cover in the Monday's class, that is in the 18th class, 18th of May, that is 16 17 is Saturday Sunday, now 18th May. So that's that's all for today's session. If there is any doubts, any confusion, any clarification, you can ask from me. So thanks a lot everyone for listening me. Thanks a lot. Now if there is any doubt, you can ask from me. In the Monday's class I'll be starting your next function, that is a write function. One more thing, please focus on this subject. This is a programming subject. Try to practice each and every program so that when I give the assignment, so it's very beneficial for you. That is how to do the assignment, how to read out the assignment. I will try my level at best with the assignment, but the main role is to you. You have to submit the assignment. I only give the assignment. You have to submit. So please focus on these subjects so that there is no difficulty in the assignment part. Alright, so thanks a lot everyone. Bye bye.